Hello learners, welcome to Dr. D.Y. Patil Vidyapeeth's Center for Online Learning. I am Professor Dattatray Katore and you are studying with me statistics and quantitative techniques. In today's video, we are going to discuss simple and multiple regression, which is Unit 5 of your course Statistics and Quantitative Techniques. In this course, we are going to discuss what is regression, what is simple regression, what is multiple regression, how the regression is different than correlation. Then we are going to discuss various regression coefficients. There are various methods of obtaining the lines of equation, lines of regression, and how they can be used in various business situations. So all these things which we are going to discuss in today's recording. So what is regression? So we will introduce simple linear regression. In a particular, we will learn when we can use simple linear regression. So in this particular topic, we are going to learn when we can use simple linear regression. Learn the basic quantities involved in simple linear regression. So we will be discussing what quantities are involved in simple linear regression. Apart from that, we will be learning how to use regression in real life situations or business situations. So this presentation is intended for learners in initial stages of statistics. No previous knowledge of statistics is required. So this is one of the very simple techniques, and every business management learner, student should understand this. Regression. So regression is used to study the relationship between two variables. Now this is what we talk about bivariate analysis. In previous units, we have discussed measures of central tendency, measures of dispersion, then we discussed frequency tables, we discussed analyzing and presenting the data. So all these things are based upon the univariate analysis, that is, we were dealing with only one variable. Now in regression we deal with two variable. So that's why regression can be bivariate or it can be multivariate when we deal with more than two variables. So in regression we may be dealing with two variable at a time or multiple variable at a time. So when we deal with two variable, it is known as simple regression, and when we deal with more than two variables, it will be a multivariate or multiple regression. We can use a simple regression in both if both the dependent variable and independent variable are numerical. So we can use regression method to find out the relationship, the cause and effect relationship between the two variables, that is dependent variable and independent variable, and the condition is that both of these variables should be numerical. And if the dependent variable is numerical but the independent variable is categorical, then it is best to use ANOVA, that is analysis of variance. Examples: the following are the situations where we can use regression. So testing if IQ affects income. Now we can judge that the IQ has some impact on income, so we will be interested to know how IQ can affect individuals' income. So IQ becomes our independent variable, and the income is the output, because the income is being affected by IQ. This is what our assumption is, our hypothesis is. So IQ affects income. So what is affecting what? So the variable which is affecting other variable is the independent variable, and the variable which is being affected is the dependent variable. So in this case, IQ is the independent variable and income is the dependent variable. Testing if hours of work affect hours of sleep, right? So this can be again an interesting claim we would be interested to test. So testing if hours of work affect hours of sleep. So in this case, again the dependent variable is hours of sleep and the independent variable is hours of work. So we our hypothesis is that hours of work is affecting hours of sleep. So hours of sleep is dependent on hours of work. So that is what our subject of interest in this particular case. Testing if the number of cigarettes smoked affect blood pressure. So the number of cigarettes smoked becomes our independent variable. So by manipulating the independent variable, we can judge its impact on the dependent variable, which is blood pressure in this case. Following are situations where we can use regression. Testing of IQ, the same slide is again repeated, so I will skip this one. Introduction to the linear regression. The Pearson correlation measures. So we have already discussed or studied Pearson correlation coefficient. Now Pearson correlation coefficient measures the degree to which a set of data points form a straight line relationship. So from Carl Pearson's correlation coefficient, we understand the degree of relationship between the two variables, whether they are moving in the same direction, whether they move in the opposite direction, whether there is a strong correlation, whether there is a weak correlation, whether there is a negative correlation or positive correlation. So all these things are known from Carl Pearson correlation coefficient. Unfortunately, Carl Pearson's correlation coefficient is not able to answer the cause and effect relationship between the variables, and that is where regression comes into the picture. And regression is very handy tool to understand the cause and effect relationship between the variables. Regression is a statistical procedure that determines the equation for straight line that best fits a specific set of data. So it is a statistical procedure that determines the equation for the straight line. So in correlation, we can just understand the covariance or the correlation between the two given variables. We do not understand the cause and effect relationship between the two variables. Also, we will not be able to find out the value of the dependent variable given the value of independent variable. And that is one of the important drawback of correlation coefficient, and that's why we have to rely on regression coefficient when we are interested in finding the cause and effect relationship, or we can find out the dependent variable given the value of independent variable. Any straight line can be represented by an equation of the form a plus bx plus a, so where b and a are constant. So let me elaborate this particular point. So any straight line, so straight line is like this. So suppose we have y-axis here, we have x-axis. So any straight line like this can be represented with the help of this equation. Y is equal to a plus bx, right? So writing bx before a doesn't affect, the sequence doesn't matter here, because bx plus a and a plus bx both are same. Now this particular this particular intercept, that is the distance from the origin to this particular point, is known as the y-intercept, and this y-intercept is nothing but this value of a, right? And what is b? B is the slope of this line, right? Change in y, this is change in y, this is y-axis, this is x-axis, this is change in y divided by change in x. So delta y, that is change in y divided by change in x, gives us the value of b, right? So this slope, the value of b is equal to delta y upon delta x, right? So from value of b, we can judge how the value of y is being affected per unit change in x, right? So how the value of y is being affected with unit change in the value of x. So that is what regression is basically. The value of b is called a slope constant and determines the direction and the degree which the line is tilted. The value of a is called as the y-intercept. So this a value is nothing but the y-intercept and determines the point where the line crosses the y-axis. So at this point, this particular line crosses the y-axis, and therefore this is y-intercept. Now let us take an example of regression equation. Y is equal to, let us take a is equal to 5 plus b is equal to 0.85 x, right? Now this a value will be equal to 5, right? The distance from origin to this particular point is 5, and this slope is 0.85. Now what does it indicate? So this is this is a constant, a is a constant, and this particular thing b, that is slope, is also a constant. But this is independent. This a is, the value of a is independent, and this is also a constant. Now suppose this slope indicates what percent change in the value of y with 1% or unit change in the value of x. Suppose the value of x changes by 1, then the change in the y will be 0.85, right? So this is the slope of this particular equation. We have already seen the scatter plot. So we have grade point average, one of the example we have taken here, grade point average, that is GPA or CGPA you can call it, and this is your SAT score. So one will be interested to find out if there is any relationship between the SAT score and the grade point average. So we got this scatter plot, and this is the line of best fit, right? So continued linear regression. How well a set of data points fit a straight line can be measured by calculating the distance between the data points and the line. So how well a set of data points fits a straight line can be measured by calculating the distance between data points and straight line. Now let me elaborate this point. So these are the distances of individual points from the line of best fit. So this is the line of best fit. So we have drawn this line of best fit. Now what is line of best fit? Line of best fit is the line we draw through these points, through this scattered diagram, in such a way that we try to keep equal number of points on both sides of the line, and apart from that we try to cover as many as points through this line. So there should be maximum number of points on this particular line, and apart from that, second condition is that there should be equal number of points on both sides of the line. So this is the thumb rule, or this is the way to draw a line of best fit. Now how best fit is this line of best fit is, that is what we have to judge, and that can be judged by finding out the distances of individual points from this particular straight line, right? So how well a set of data points fits a straight line can be measured by calculating the distance between the data points and the line. The total error between the data points and the line is obtained by squaring each distances and then summing up the squared values. So this is called a sum of square method. So we will not go in detail with that because this is part of econometrics. So let us understand only this point, that how well a set of data points fits a straight line is dependent upon the distance of all the points from the line. The regression equation is designed to produce the minimum sum of squared errors. Simple regression least square method. So we are now going to talk about the simple regression. So it is a mathematical procedure for fitting a line to a set of observed data points in a manner that the sum of the squared differences between the calculated and observed value is minimum. So that is what the simple regression is. The linear trend is the most widely used mode of time series analysis. So simple regression equation with the least square method is continued. Let me elaborate this particular point with the pointer. Now this is the straight line equation which you must have studied in your mathematics course in your school days. So y is equal to a plus bx. So this is the straight line equation, as we already discussed in this particular unit also, in this particular video also. So y is equal to a plus bx. Now if we find out these two values, value of a and value of b, we get an equation. For example, y is equal to 5 plus 0.85x. all right. So once we get the value of a and the value of b, we can answer, or we can find out the value of y given any value of x. So by manipulating the value of x, we can get the value of y. So this is the equation of y on x. Y on x means we can find out the value of y given the value of x. Right. Similarly, there is a x on y equation, but we are more interested in y on x. Okay, because y is generally the dependent variable and x is independent variable. That's why we are more interested in the equation of y on x. So this is y on x equation, and by finding out the values of a and b, we get an equation, equation of a straight line. So these are the only two things required to draw a line. One is y-intercept and the second is the slope of the line. Once we know these things, we can draw a straight line. So by manipulating the values of x, right? So that's why these two values are important for us, a and b, right? Y and x these are the variables, right? By manipulating the values of x, that is the independent variable, we can have the value of dependent variable y. So this is what we want, a and b. Now how to find out the values of a and b? So I'm writing this equation here again. Y is equal to a plus b, a plus bx. All right. Now taking a summation on both sides. Summation means addition sign. This is the summation, which is a very common or simple mathematical concept. Summation of y is equal to, now we have to apply summation on right hand side also. So this will be equal to summation of a plus summation of bx. Now what is summation of a? Addition of a. So summation of a is nothing but summation of a is equal to where is equal to a plus a plus a plus up to a. So n number of times we have to add a to a itself. So this will be equal to na. So when we are adding any particular number n number of times, simply we can multiply n multiplied by that particular number. So for example, we are adding 3 4 number of times, 3 plus 3 plus 3 plus 3. So this will be equal to 4 multiplied by 3. So 4 3s are 12. Similarly, when we go on adding a n number of times, this will give us n na. So this summation of a is equal to na. This will remain same. We'll take b out. So b summation of x, because b is a constant. Then we have summation of y here. Right, now this is a least square method of finding out the values of a and b in order to find out the equation of y on x. So similarly, now what we will do, we will this is our equation 1, for example. This is our equation 2. Right, now we are going to multiply equation 1 by x. So on left hand side we will be having xy. Right, so we are multiplying left hand side of this particular equation 1 by x. On right hand side we will be having ax, right, a multiplied by x plus b multiplied by x, bx multiplied by x, that is bx square. And now again we will take summation on both sides. So what we will have, summation of xy is equal to now this is ax actually. So a will be out. This will be summation of x plus b will be out of summation, then this will be b summation of x square. Now this is our equation 3. Right, so why we have formed these equations? Because we can put these values. What we are intended to do, we have to find out the values of a and b. We have to find out the values of a and b, and by putting the values of a and b in this particular equation, y is equal to a plus bx, we can have an equation like this: y is equal to 5 plus 0.85 x. So that's why we are interested in finding out the values of a and b, and that's why we have formed this equation. Now what we can do with these equations, we can put summation of these values, summation of x, then this value na, then summation of y, summation of xy, summation of x, summation of x square. So by putting all these values in these two equations, we can have two equations in a and b. Right, so there will be two unknown a and b, and we'll be having two equations, and by solving these two equations, so we will be getting the values of a and b. So that is what we want. So we'll be studying one problem on this, so you have to remember these equations. So this is a least square method. Right, years. So let us continue with an example. Now we have an example here. The data relate to the sale of generator sets. So we have a data relating to the sale of generator sets of a company over the last 5 years. So we have 5 years data. So this is a time series actually. What is the time series? We have data and time period. So time is the independent variable in this case, and generator set is the dependent variable in this case. So this is a trend series actually. So we have data corresponding to some time period. That is what a trend series is. So 2003 data is 120 generator sets. So this is actual data, and 2004's sale of generator is 130 units, 2005's sale of generator is 150 units, and so on. And what is required? We are required to estimate the demand for generator sets in the year 2012 if the present trend continues. So we have to find out the demand for generator set in the year 2012 if the present trend continues. So we are believing that this trend will continue in future also, and on the basis of that we have to find out what would be the demand for the generator sets in the year 2012. So this is the application area of regression. So what we have to do basically, again we have to write those two equations which we have learned. Let me write them here again. So what was that? Summation of y is equal to na plus b summation of x, and then summation of xy is equal to a summation of x plus b summation of x square. Now look at these two equations. What we need? Summation of y, summation of xy, then we need this n, then summation of x, summation of x, summation of x square. Now this is given in the problem, year 2003, 2004, 2005, 6, 7, right? And these y values means our dependent variable, sale of generator set. So this is also given in the problem. So year is given, and dependent variable y is also given. Now what is this x? Now these values 2003, 2004, 2005 are too large. So instead of using 2003, we assume that 2003 is equal to 1, then 2004 is equal to 2. Now this is the this is the magic of regression. We can do things like this in regression. So what we can do, 2003 is equal to 1, analogous to 1. Then if 2003 is equal to 1, then 2004 will be equal to 2, 2005 will be equal to 3, 6 will be equal to 4, and 7 will be equal to 5. And what we are interested in, finding out the sale of generator sets in 2012. So if 7 is 5, then 12 will be equal to 10, right? If 6 is 4, then 12 will be equal to 10. So we are interested to find out the value of y when the value of x is 10, right? So this is what we are interested to find out. We have these two equations. Now by putting the values in these two equations, we can find out the values of a and b. That is what we want, so that we can put the values of a and b in this particular generalized equation, and by using this generalized equation we can predict the sale of generator sets for any year, right? For this particular example, we have to predict it for the year 2012. So what we have done here, we have x values, we have y values. So summation of x here, this is summation of x, 15, 1 plus 2 plus 3 plus 4 plus 5. What else is required? Summation of y, right? 120 plus 130 plus 150 plus 140 plus 160 plus 700. Then we need, what else we need? According to our need only we have formed this particular table. So we need summation of x square also. So here is x square, 1 square is 1, 2 square is 4, then 3 square is 9, 4 square is 16, 5 square is 25, and so on. So we have summation of x square. So 1 plus 4 plus 9 plus 16 plus 25 is equal to 55. What else do we need? We need summation of xy. So we have to multiply x with y, right? X with y. 1 multiplied by 120 is 120, right? Then 2 multiplied by 130 is 260, and so on. So this is how we can calculate xy values, and here we will get addition of all these. Now we have got all these values, summation of y, summation of xy, summation of x square, right? So by putting all these values in these two equations, we will be having two equations. Okay, let me check eraser. I'm erasing this particular equation for now. Okay, now summation of y is equal to what? 700. Now the first equation becomes 700. What is n? N is the number of data set. 1, 2, 3, 4, 5. 5 years data. So 5a plus b multiplied by summation of x. Summation of x is 15, right? So we have this equation. 5a plus 15b is equal to 700, right? Now we will be putting values in the second equation also. Now what is summation of xy? What is summation of x? Summation of x is 15. So 2190 is equal to 15a plus what is summation of bx square? So summation of x square. So summation of x square is 55. So this will be 55b. So we have this second equation, 15a plus 55b equal to 2190. So basically we have two equations, 5a plus 15b is equal to 2190. Now these are the two equations, and in these two equations there are two unknowns, a and b, and when we have two equations and two unknowns, we can solve these two equations to find out the values of these two unknowns, a and b. And once we get these two values, we can have this y is equal to a plus bx. For example, y is equal to 5 plus 0.85 x, right? So this kind of generalization you can have, right? So that is equal to 5a plus 15b, the same equation. Yes, the same equation. 5a plus 15b is equal to 700. So this is that equation. 5a plus 15b is equal to 700, and 15a plus 55b is equal to 2190. Now by solving these equations simultaneously, we can get the values of a and b. So by multiplying the equation 4, so suppose this is equation 4 by 3, this is 4 actually. So by multiplying this particular, what we will get, I'm writing it here. 7 3s are 2100. This is equal to 15a plus 45b, right? And the second equation we will write as it is, 2190 is equal to 15a plus 55b. Now I will subtract this equation, that is minus 2100 minus 15a minus 45. This will give me 90, right? 15a minus 15a is 0, and 55b minus 45b is 10b. So b will be equal to 9. So we got the value of b. Here it is. We got the value of b, and by putting the value of b in the equation, in any of these equation actually, so by putting the value of b in any of the equation, we can get the value of a. Here it is. So say b in this particular equation. So 700 is equal to 5a plus 15 multiplied by 9. So 15 multiplied by 9, this will be equal to 135, right? So 5a is equal to 700 minus this 135, this is equal to 565. So 5a is equal to 565, a is equal to 113. Now by putting the values in this equation, y is equal to a plus bx. So y will be equal to, and b is 9x. Now we got the equation, the general equation for the sale of generator sets, and we know that we have assumed that 2003 is equal to 1, and therefore 2012 will be equal to 10. So by putting the value of x is equal to 10, we can get the value of sale of generator set for the year 2012. So y is equal to 113 plus 9 tens are 90. 90 plus 113 is equal to 203. So y is equal to 203. So this is the predicted sale of generator set for the year 2012. So regression can be calculated by without least square method also. This the regression method, the direct or shortcut method rather than the least square method of simple regression. And apart from the simple regression shortcut method, we are going to discuss multiple regression. So starting with simple regression, direct and shortcut method. So let me elaborate with some example. Now in previous discussion, we have seen that the regression equation is given by y is equal to a plus bx. So by finding out the values of a and b, we can find out the regression equation, and so that we can manipulate the value of x to get the value of y, which is a dependent variable. Now we can have a direct method also to find out the regression equation. And in direct method, what do we do? As I already told you that there are two types of regression equation, x on y and y on x. So x on y equation is given as x is equal to x minus x bar is equal to bxy y minus y bar, where x is these x values are the individual x values from the data series, and this x bar is nothing but the arithmetic mean. Then bxy is the regression coefficient of equation of x on y. Then we have y minus y bar, where y bar is the arithmetic mean of y data series, and y are the individual values of y. So this is x on y equation. So by putting the values in this equation also, we can find out the regression equation. For example, we can have x bar value, we can have y bar value, then we can calculate these values also. Look at this equation. This equation bxy. So we can have summation of xy, then summation of x multiplied by summation of y, then summation of y square minus summation of y bracket square. So by putting all these values, we can calculate this regression coefficient, which we can put here in this particular equation. So by putting this regression coefficient as well as x bar and y bar values, we can have an equation in x and y. So that will directly give us the value of the equation of x on y, right? So similarly, there is a y on x equation. So y on x, we are more interested in y on x equation because y is the dependent variable and x is the independent variable. So y on x equation is given by y minus y bar is equal to byx. Now byx is the regression coefficient of the equation y on x, then x minus x bar, right? So similarly, we can use this particular formula for the regression coefficient, which we can put here, right? So we can put the values of y bar, x bar and byx to get the equation of y on x, right? So this equation is more important than x on y, because we are interested in finding out the value of the dependent variable given the value of the independent variable. So in this case, independent variable is x and dependent variable is y. So this is the y on equation. So whether you use this particular form, y is equal to a plus bx, or you use this equation, the result will be same. Alright, so in previous example also you can use this particular equation. So as a practice or as a homework, you are supposed to use this particular method, direct method. For the previous problem we have solved by using the least square method. So use this particular formula of byx as well as equation of y on x to find out the cells of generator set for the year 2012, as we have discussed in the previous part of this particular video. So this is a direct method. By putting this value directly, you can get the regression equation of y on x. Once you get the regression equation of y on x, you can manipulate the values of x to get the different values of y, because x is the independent variable whose values can be manipulated to get the values of y, corresponding values of y. Regression method. So linear regression analysis establishes a relationship between a dependent variable and one or more independent variables. So in simple linear regression analysis, there is only one independent variable. So as we have seen, in case of simple regression, there is only one dependent variable and only one independent variable. For example, y is a function of x, right? So y is equal to a plus bx, right? So this is the equation of y on x. So in simple linear regression, there is only one independent variable. So here is the independent variable. And in case of multiple regression, there will be more than one independent variable. For example, y can be a function of various variable like x1, x2, x3 and so on. So this is multiple regression. So there are more than one independent variables. There is only one dependent variable. So if the data is time series, the independent variable is time period. So as we have solved one example on time series also, where the independent variable is time period. The dependent variable is whatever we wish to forecast. So these were the regression coefficient for the direct method we have already discussed, right? So in previous method what we studied, yes, let me again elaborate this. Yes, so we can have equations like x minus or y minus y bar is equal to byx, that is the regression coefficient of y on x, multiplied by x minus x bar. So you can use this particular value of byx and you can obtain the regression equation of y on x directly. Or suppose you have to find out the x on y equation, then x minus x bar is equal to bxy multiplied by y minus y bar. So in this case you can use this bxy regression coefficient. So you can put this value in this particular equation, then x bar and y bar values, you get the equation of x on y. Now there is again one more method to find out the equation of regression equation. So let us again come back to the original equation which we have studied earlier, y is equal to a plus bx, right? So in this case also we can directly place the values of a and b without finding out the least squares which we have done in the previous part. So we can put the values of a by this particular equation. So you can find out the value of a by using this particular equation, and you can find out the value of b by using this equation, and you can directly place these values here to get the equation of y on x. So I suggest you to use these equations, direct method, as well as these equations to get the equation of y on x for the previous example. So here we have one more example. The data of the firm relating to sales and advertisement is given below, and if the manager decides to spend rupees 30 mil in the year 2005, what will be the prediction for the sales? So we have year, so this is again a time series data, and against which we have advertisement expenditure and sales. So what we have to find? A manager decides to spend rupees 30 mil in the year 2005. So he decides to spend 30 million. Okay, 30 million. Let me check the pointer. Yes, 30 million for the year 2005, and he is interested to find out the sales value. Now this is the equation, or this is the problem of multiple regression, because we have two independent variable and one dependent variable. So here sales is supposed to be a function of what? Year and advertisement expenditure. So there are two independent variable, and that's why this is a case of multiple regression. So this is how we can find it out: year, then advertisement expenditure, right? Then sales values are given here, and then we calculate x square values, xy values to put them in the equation. So using the formula, the calculated values of a and b are: a is equal to 34.54 and b is equal to 2.15. So this is calculated by using these equations. Look at these equations, these two equations. This is the value of a, this is the value of a, yes, and this is the value of b. So by using these two equations we can find out the value of a and b. So here it is: a is equal to 34.54, b is equal to 2.15. So by putting all these values in the equation, y is equal to a plus by, we get the equation of y on x, and then we can put the value of y is equal to 30 to get the value of x is equal to 30 to get the value of y. Multiple regression. So as already discussed, in multiple regression there are more than one independent variable, and by putting the values, by manipulating the values of these two independent variables, we have to predict the value of dependent variable. So this is the equation which we use here. So I will write it again. So this is x minus x1 bar, x1 minus x1 bar. This is equal to b1 2 dot 3. Then we have x2 minus x2 bar. Then we have b13 2 multiplied by x3 minus x3 bar. So you can put the values of, now this is the equation of x1 bar on x2, x1 on x2 and x3, because x2 and x3 these are independent variable, and by putting the values of x2 and x3 we are interested to find out the value of x1. That's why this is multiple regression. So by putting all these values, now b1 to 3 can be calculated by using this particular equation, right, and b132 can be calculated by using this particular equation, and you can put the values of x1 bar, x2 bar and x3 bar, and then you will get the equation of x1 on x2 and x3, right. So this is what multiple regression is. So thank you so much for watching this video. Watch both the parts of the video so that you will understand the concept in entirety. Once again, thank you for watching.